right, we're going to go ahead and get started. Those of you in the very back, you could feel free to come forward. Those are some impressive nosebleed seats up there. I'm not going to be joining you during my session. I normally like to walk around a little bit, but that's a little too far. So my name's Jeff Mieleff. I'm a program manager in the Office 365 team, and I focus primarily on Exchange. And one of the many roles that I have at Microsoft is sort of the virtualization ambassador for the Exchange team. I've been responsible for the last couple of releases for setting our support policies and working with the engineering component teams and figuring out what we do and do not support and what we can potentially make better in the product moving forward when we think about deploying Exchange on a virtual platform. So first of all, thanks everyone for showing up. Hopefully we can use this time and use this time well and get some good information across. So in terms of what I want to talk about today, I want to spend a few minutes talking about why and why not when it comes to virtualization. Historically, Exchange has had some kind of mixed messaging around virtualization and whether or not it makes sense for Exchange or whether or not the product group wants you to do it. That's not really what I'm going to talk about. I don't really care if you virtualize. At the end of the day, what I want to make sure is that you're going to have a good experience with the product, that you're going to be in a supportable state so that if you run into problems and need to pick up the phone and call Microsoft for help, we can do that in a very efficient way. And I want to make sure that all the users who are accessing your servers are going to have a great experience with the product. That's my goal. Obviously, when it comes to combining Exchange and a virtualized platform, there are some benefits that you can get out of that, and we'll talk through some of those as well. But we'll also talk through some of the negatives that can come up and how to avoid those. So we'll talk about the specific supportability guidelines for virtualizing Exchange 2013 and how those might impact your deployments. We'll talk briefly about sizing recommendations. So there are some specific tweaks when it comes to sizing around deploying Exchange on a virtualized platform. It's going to be a very quick discussion because there aren't a lot of tweaks, but important to bring them up. And then, like I said, we'll probably spend the bulk of the time talking through some of the problem areas and best practices in terms of how to avoid those problems. I do expect that we'll have time for a few questions. This kind of room isn't the best for Q&A. So if you don't have an opportunity to ask questions or don't feel comfortable doing it in this environment, come on down to Ask the Experts this evening, and I'll be there along with a number of my colleagues for the evening, and we're more than happy to go into more detail on this. So why do people virtualize Exchange? In general, this concept is going to be applicable across any sort of application. There's nothing special about Exchange that would cause you to want to virtualize it. One of the primary reasons that I hear from customers that I work with is server consolidation. And that's been a very common reason to virtualize anything since virtualization became a very common thing in recent years. Homogeneous infrastructure is also another very common reason for virtualizing, right? Having this will be the first use of the word cloud in my talk this afternoon. Having a private cloud deployment where rather than thinking about specific types of servers or specific hardware resources for Exchange, instead I'm thinking about a pool of resources that are available for all of my applications, and I just allocate resources out of that pool as I need them. That's a very appealing mode of deployment, right? Now that assumes that you have that pool there and that it's being well managed and that you have those resources available to you when you need them. So, it's not a magic pool of resources that just appears overnight. You do still have to manage that infrastructure, but there certainly are benefits around homogeneous infrastructure like that. Hardware utilization. So this is, from an Exchange perspective, something that I think has been more true in previous releases than it will be in Exchange 2013. In previous releases, because of the architecture of the product, we didn't do a great job utilizing hardware, particularly in 2007, somewhat in 2010, prior to our recommendation to deploy multi-role. Those two products, because of the single role type of deployment and each role having different demands on different types of hardware resources, you ended up with wasted resources on the table on many of those servers. If you virtualize those single role servers, you ended up getting better utilization of hardware overall. But at the same time, frankly, that's the reason that we went down the multi-role path in 2010 and really started to advocate that, was a much better utilization of hardware resources. And that's the exact same reason that we made the architectural change in 2013 on the mailbox role to combine the former CAS and hub roles with the mailbox role for a single, unified, well-balanced server role. So this is less true today than it used to be. But there certainly is a perception that virtualization can somehow provide better hardware utilization. And then cost. I rarely have a conversation with virtualization about virtualization with customers that doesn't involve cost. There certainly is a perception and often a truth that virtualization can save cost. It's not always true, and there are certainly ways to deploy Exchange on physical hardware at a very low cost. In many cases, cheaper than you might if you were virtualizing. That varies. And there's no way that I can stand on stage and say that for every customer it's going to be cheaper one way or the other. It's going to be very specific to your requirements, your business requirements, whether or not you're already virtualizing other applications, whether you are deploying applications in a private cloud. These are all factors that go into that cost equation. So it's going to vary, and it's going to be a very unique decision for you. So why not? Why wouldn't we virtualize? Well, I think one of the best arguments that I have for not virtualizing is around complexity. So Exchange is a fairly complex product. I think we've gotten rid of a lot of complexity release to release. It's a lot simpler to deploy in 2013 than it used to be, that's for sure. Though I guess maybe, I don't know, we've kind of gone through some cycles. We'll leave it at that. 2003 was simpler as well. But anyway, if you virtualize Exchange, what are you doing? Well, you still have Exchange running on an instance of the OS that you have to manage, right, in that virtual machine. That instance of the OS is now running on a hypervisor that needs to be managed, monitored, patched, etc. From a hardware perspective or a infrastructure perspective, where with a physical deployment, you might have had some options around things like JBOD DAS, as an example, with your physical servers. When you go down the virtual path, in many cases, you're adding some additional complexity around your storage configuration because you want to be able to take advantage of some of the functionality that comes with a virtual deployment, right? You want to be able to live migrate or vMotion your virtual machines around, right? In order to do that, you're likely, not necessarily, but likely going to go with a shared storage model with a SAN. And you're adding some additional complexity into the deployment that you wouldn't have had otherwise. That's what I'm talking about when I refer to complexity as a reason that you might not want to virtualize. You're adding additional complexity in terms of management, monitoring, patching, and overall solution design, where you don't necessarily need that. Additional deployment steps, somewhat related to what I was just describing. So you still have to deploy Exchange. You still have to deploy those OS instances. And you also have to deploy the hypervisor. Additional management layer. Kind of sounds like I'm harping on these things now because it's a little repetitive. But it is an additional set of tools that you're using outside of what you would use to manage Exchange and the OS. Now, obviously, there's a flip side to each one of these arguments. From the additional management layer perspective, this kind of fits into one of the benefits on the virtualization side, that you may actually gain access to some other tools that you wouldn't have access to in a physical deployment to manage that broad virtual infrastructure or that cloud deployment. So this might not be a negative. It might actually be a positive, depending on your specific situation. And I've mentioned monitoring as well. There is going to be a minor performance impact here. Virtualization isn't free. You're adding an additional layer between an application and the hardware, right? It's a no-brainer. There's going to be a cost. And yes, there is marketing out there that will tell you that Exchange runs better virtualized than it does on physical. I haven't seen that for 2013, but it has been advertised with prior releases that that's true. And it's not. That is not true. There is going to be a CPU cost to virtualizing. There will be for every application. So it's a minor cost, but it is an added cost. It's not free. There certainly are workloads that are not compatible, or that are not compatible with certain aspects of the functionality provided by a hypervisor. So there are aspects of the functionality set of Hyper-V that Exchange doesn't support, and we'll be talking about those in a few minutes. Same with VMware as well. There are aspects of what is provided by third-party hypervisors that Exchange does not support. And if those are the features that you really want to get something out of, then obviously that might not be a good reason to virtualize if you're not going to be able to take advantage. Then cost is another why not, right? You're adding some additional licensing costs in some cases around deployment if you decide to virtualize. Out of curiosity, I'm not making a statement one way or the other in terms of hypervisors. I'm just curious. I always ask this every time I deliver this session. I'm always very curious to see the answer. How many of you today are virtualizing Exchange in production? Okay. That's actually fewer than usual. I saw more hands not being raised than I'm used to. How many of you are using Hyper-V to do that today? Awesome. And how many of you are on VMware? How many of you are on something other than Hyper-V or VMware? No Citrix Zen folks out there? Okay. Oh, I see one hand up there, way up there. All right, cool. Okay, that's useful, unscientific market research for me. Helps me to know where we should spend our time when we think about guidance. So, is there a clear answer for me? No, of course not. It depends. Ideally, if we don't have a clear, simple answer for you around guidance, simplicity should always rule. We would love it if everyone chose the simplest Exchange deployment possible. I realize that's not always going to happen, often doesn't happen. I get involved with a lot of Exchange deployments where people have gone in the exact opposite direction and tried to make things as complicated as possible. That's always a challenge. But from the perspective of virtualizing a deployment, if you don't have a good reason to virtualize, don't do it just so you can say you virtualized and check a checkbox. I want you to get something out of it. That's really the message you should take home around whether or not to virtualize Exchange. Don't do it just because it sounds cool and it seems like the right thing to do. We don't really build Exchange to be a great consumer of a virtual platform. We build Exchange to run great on Windows and to provide a fantastic email and collaboration solution. And the infrastructure that sits beneath us, we don't really care as long as we get the resources we need. So if it's virtual, that's fine. If it's physical, that's fine too. But at the end of the day, what we want is simplicity at that layer, right? We don't want extra complexity. So that's what you should keep in mind. We think that physical is often going to be the simplest solution, but it isn't always. There may be situations where physical is not the simplest solution, so by all means, virtualize in that case. It absolutely makes sense for a subset of our customers. We recognize that, totally embrace it, and that's fine, right? And like I said, we really want you to get something out of virtualizing. That's really the key. take advantage of live migration to be able to move workloads around and rebalance things and patch host servers on the fly without impacting a workload. As long as you're getting some advantage by doing so, fantastic. That's great. So let's talk about supportability. We'll start off by mentioning Windows Server 2012. I'm a huge fan of Windows Server 2012. In terms of the Hyper-V functionality in Server 2012, there's some great advantages for Exchange. Probably the biggest in my mind, given that I'm a scalability and performance geek, is the virtual CPU limit effectively being removed. I have not been a huge fan historically of deploying Exchange on Hyper-V prior to Server 2012 simply because of that 4 vCPU limit. Made it very difficult to size an Exchange deployment when all of your Exchange servers needed to be 4 vCPU. Most of the deployments I work with are fairly large, and it artificially inflated the number of Exchange servers you needed. Kind of hard to argue for deploying virtual if you're going to have that type of limit. And I think it led many people to alternate hypervisors. This is a great reason to deploy Hyper-V if you're going to virtualize Exchange. The increased per virtual machine memory that's available in Server 2012 is also huge for us. No pun intended, because we do have some increased memory requirements in Exchange Server 2013. So we're happy to be able to take advantage of that sizing limit being dramatically increased. We think that if you virtualize Exchange, if you do it on Server 2012 and you size things properly, you're going to have a great experience. Probably, well, you will have the best experience for a virtual Exchange deployment. I say that for one very good reason. This is, without question, the most tested combination of hypervisor and Exchange. We run thousands of virtual machines every day. Many, many thousands. Effectively, every test that's run on Exchange, in terms of our daily builds and our automated quality validation processes that run prior to actually making changes to our code base, all run on virtual machines. There's really no way that we could do what we do from a test perspective without this technology. All of that runs on Hyper-V. We have a feedback loop as well between Exchange and Hyper-V. It's Microsoft. We're the same company. We have some great communication going on between the two teams in terms of the direction that the Hyper-V team is headed and the direction that the Exchange team is headed. Obviously, as you may have noticed from an architectural perspective, those don't always meet up. But in general, there are areas where we have some good overlap and some areas where we do a good job working together and making sure that we're doing the right thing around customer guidance and supportability. We also have a great engineering relationship where we have a great understanding of how Hyper-V works underneath the hood, and we can make sure that we're doing the right things in our product to ensure great compatibility. So, what's supported? If you've looked at virtualizing Exchange in previous versions, this will probably look very similar when we think about how we support Exchange 2013 virtualized. Very, very similar here. In terms of supported hypervisors, you're basically looking at the versions of Hyper-V that are associated with the OSs that we tested for Exchange 2013, as well as third-party hypervisors that are covered under the Windows Server Virtualization Validation Program. So that would include things like VMware, Citrix-Zen, et cetera. You do want to make sure that the hypervisor that you're using, the particular version of it, is actually included in the SVVP program. They're not all included. There is a certification process or a testing process that those vendors need to go through to actually get their products listed. So be aware of that. There are certain versions, newer versions, that are not currently on that supported list. In terms of Exchange roles, all Exchange roles are supported for virtualization. We only have 2 now, so that's really easy for us to do. So Mailbox and CAS, or the combination of Mailbox and CAS together in a multi-role deployment, absolutely supported. And by the way, if you missed the sizing session earlier or any of the other sessions where we've advocated deploying multi-role, I'll say it again here. We think that deploying a multi-role Exchange 2013 server is absolutely a best practice, and it's going to be a best practice virtualized as well. It dramatically simplifies things and provides higher availability by increasing the number of CAS servers in the deployment. So keep that in mind. Around storage, we basically have the same requirements as Exchange 2010. Storage needs to be block level. We don't support dynamically expanding virtual disks. You can use iSCSI. You can use pass-through volumes, et cetera. All these same things that we've historically supported continue to be so for 2013. There is a caveat to that. That's what the asterisk is for, and I'll get to that in just a second. Around host-based clustering, what I'm referring to there is the ability to take a group of hypervisor hosts. This could be Windows servers, could be VMware machines, could be any hypervisor technology that allows you to essentially cluster those hosts and fail over virtual machines in case there's some sort of a network outage or a hardware issue with one of the physical hosts. We do support host-based clustering. The caveat there is that you need to make sure that when failovers occur, that those Exchange servers are coming up fresh. They're coming up from basically a cold boot. Cold boot has an interesting meaning in the virtual world, but those machines can't be running, right? Now, if you think about it, that is kind of an obvious requirement. If the hardware dies on a hypervisor host, how is a virtual machine that's running on that hypervisor host going to come up on another machine still running? Right? It doesn't happen. It can't happen. But I'm just calling it out there because that's what our support guidelines say. The machine needs to come up from cold boot. In terms of migration, what I'm talking about here is live migration or vMotion on the VMware side. We absolutely support that for Exchange 2013, all of our roles. We don't support quick migration, which is an older Hyper-V technology that actually saves the state of a virtual machine to disk, moves that storage to another physical host, and then brings the machine back online. That's not supported. As long as the virtual machine actually remains running effectively for that entire time period that the migration's happening, you're golden. That's absolutely fine and really cool technology. It's awesome. We also support jet stress testing in guests. This is something we started supporting last year, and I'm going to keep bringing it up because I think it's really important. Historically, we did not support running jet stress in virtual machines. There were some issues with performance counters and reliability of results coming back from jet stress, so we didn't support it. We've gotten past those issues as long as you're running the supported versions of Hyper-V or on the VMware side at least ESX 4.1 or newer. Those are the hypervisors that we've tested and are comfortable with. Absolutely run jet stress on those virtual machines. It's the best way to know whether or not the storage subsystem sitting behind those VMs is capable of meeting the demands that that Exchange is going to put on the storage. And I would argue that it's even more important here than it is in a physical deployment. The reason for that is very often in a virtual deployment, you have a shared storage infrastructure where you have multiple workloads accessing shared storage. It's not dedicated to Exchange in any way. And there can be a lot of unknowns in terms of the available performance from that storage and how it's going to respond at times of peak demand from an Exchange perspective. Running jet stress against that storage, great way to figure that out. The link at the bottom of the screen is a little quick alias to the official page on TechNet that describes the support statement for Virtualized Exchange 2013. So what's up with that asterisk? We have chosen in 2013 to change the storage supportability guidelines just a little bit to include storage of virtual hard drives, VHDs, on SMB 3.0 file shares. So this is a new feature in Server 2012 that takes advantage of massive improvements to SMB in Server 2012. And basically what we're talking about here are shares coming from a Windows Server 2012 machine or cluster of machines, or other implementations of SMB 3.0. We don't specify that it has to be Server 2012 presenting the storage. And it's specific to VHD storage. So this is only for virtual disks, not for mapping Exchange directly to an SMB share. So you can't go and run new mailbox database and set the path to be a UNC path that's an SMB 3.0 share. That won't work. You will get an error. I guarantee you will get an error. So we need the hypervisor to basically make that UNC path transparent to us, right? So we're not making any changes to our support of down-level SMB or any other NAS technology that exists. We still do not support those for use with Exchange. This is just SMB 3.0 and just for VHDs, VHDXs, any sort of virtual hard drive file. So what does that actually look like, and why did we choose to support it? So I grabbed a few images from some of the documentation on SMB 3.0 storage. This just provides a little set of images around the different scalability of SMB 3.0 with Windows Server 2012. So on the left, the bottom of the screen, I have a very simple deployment with two Hyper-V root servers, two Hyper-V parents, and that's the terminology they used in this set of images, that are basically connected to a single file server cluster. Could be actually a single server in this case, with a couple of disks sitting behind that. Very simple, fairly easy to set up for a lab. At the low end of the scalability spectrum. In the middle, we have a couple of file servers that are clustered, most likely, and they're using shared SAS storage. So both of those file servers have access to that shared SAS storage, and if one of those file servers dies, the other file server in the cluster can take over and continue to provide access to that storage. That's sort of a mid-range example of the scalability of this type of solution. And then on the right side, we have a large fiber channel storage array. You could think of this as a big SAN in the back with a number of file servers. We're basically scaling out the number of file servers that are fronting that storage. All those file servers have access to the disks sitting behind, and they can provide that access to Hyper-V as necessary and deal with hardware failures at the file server level. So go from very simple on your left, very simple and very minimal investment at the low end of the spectrum, up to a fairly complex deployment. We really like this from an Exchange perspective because actually across the board, it's a fairly simple deployment. It really fits in with the large low-cost disk sort of messaging that we've had around Exchange for the last couple of releases. And we think that if you do want to take advantage of virtualization, and you do want to take advantage of some of the features that come with virtualization that require shared storage, this is a great way to get there in an inexpensive, simple way. And allows you to also obviously utilize large low-cost disks, deploy large mailboxes, and get all those great benefits that come from that type of deployment with Exchange. So typically get asked, why not NFS? Why haven't we done the same thing with NFS? And the answer really comes down to variability in NFS, right? What is NFS? Well, there's a whole bunch of different implementations of it. I know there's an implementation in Windows. I don't know if I'm not sure that we ship it anymore in Server 2012 or not. Anybody from the Windows team here? No? Anyway, I'm guessing that our implementation of it's probably not the best. Certainly not something I would imagine we concentrate on all that much from an engineering perspective, but it's a standard. Implementations are going to differ around that standard, and we really have no way to say across the board, NFS is great, you're golden, you can use it for storage of Exchange virtual machine data. We've had a number of challenges historically with support incidents that we've had to deal with around performance and reliability. And reliability is generally the bigger concern for us. Performance you can usually engineer around. Reliability, in the worst case means data loss. I'm not saying that these were cases where we had data loss, but could be. But in a sort of minimal scenario with reliability, you're probably at least looking at database reseeds, that type of activity in dealing with issues around NFS reliability. So we don't support NFS for Exchange storage, virtual or otherwise. That's really the background there. So migration. I want to bring this up. So the first time we announced support of live migration and vMotion for virtualized Exchange servers was actually at the last TechEd in New Orleans. It's been a few years. It was in a much smaller room. But since then, even though we've continued to talk about it over and over and over again, I still get questions about this. So I do want to bring this up yet again. We absolutely support live migration and vMotion with all Exchange roles. There's no question about that. We absolutely support it. I mentioned not supporting quick migration earlier. That continues to be true. We don't support any migration technology that's basically saving state to disk and bringing up a machine from a previous point in time. We don't. Exchange does not deal well with that. That's why we don't support it. Same reason we don't support snapshots. So let's talk a little bit more about what's not supported. So in Server 2010, Exchange Server 2010, we highly recommended that you not use dynamic memory, memory overcommit, any sort of memory reclamation technology. That's sort of the broad terminology around these different options that exist in Hyper-V and other hypervisor platforms. In 2013, we took it a step further and we're saying not supported, period. The reason for that is actually two reasons. We want it to be simple. We want our guidance to be simple, straightforward, easy to understand, not wishy-washy. And we've also gotten an awful lot of support incidents from customers who were using these types of technologies with Exchange in production and ran into very severe performance issues. And we wanted to make sure that wasn't going to happen. Like I said, I think my role and the role of the folks I work with on the Exchange team around developing this guidance is to make sure that you're on a path to having the best experience possible with Exchange, and your users are going to get the best possible end user experience with the product. This is one of those changes that we've made to encourage that. So the guidance for Exchange 2013 is that to stay in a supported state, you need to configure static memory for your Exchange virtual machines. What does that mean? It's going to be different depending on your hypervisor. For Hyper-V, that's going to mean not using dynamic memory. For a third-party hypervisor, it's going to have different definitions. Basically, you need to make sure that Exchange always has the memory that it was configured to start with, and that that's not going to be changing over time behind the scenes. That's what that means. In terms of hypervisor snapshots, I'm not talking about VSS snapshots that you might use for backup. I'm talking about the ability of a hypervisor to take a point-in-time snapshot of a virtual machine and then roll back to that snapshot at some point in the future. Cool technology. Excellent for building test labs. Fantastic for that, right? The ability to go build an Exchange deployment, snapshot all the machines, go, make some configuration changes and see what the results of those changes are, and then, if you need to, roll back to that previous point in time and make some other changes. Very, very useful technology. Doesn't work well in production with Exchange, particularly if you have a DAG. Exchange does not deal well with individual machines in a DAG magically appearing at some previous point in time. Any sort of distributed system where you're replicating data tends to not play so well with these types of technologies. So that's the challenge for us around snapshots and why we don't support it in production. Differencing and delta disks are the storage technology that sits beneath snapshots. So because we don't support snapshots, we don't support differencing or delta disks. That's the reasoning there. We also don't support running applications on the root. This is more of a Hyper-V thing. Basically what I'm saying is don't build out a Server 2012 machine deploy a bunch of Exchange VMs on it, and then run SQL on the Hyper-V host or some ERP system, right? The way resources are allocated on that machine, you'll actually end up potentially having a very detrimental impact on those Exchange virtual machines that are running in that configuration. So on the root, you want to deploy any sort of management, monitoring, antivirus, any of those types of tools that you would normally use to keep those machines up and running in your data center. By all means, absolutely deploy those. Just don't deploy server workloads running on the root. And then the last point is that we don't support what we consider significant processor oversubscription. And what we're talking about here is making sure that Exchange has the CPU resources that you sized for when you built the VM. If you go and oversubscribe CPU on a hypervisor host, what you're effectively doing is allowing other virtual machines on the box to take more than potentially their fair share of CPU. And there are some ways to mitigate that. There are configuration parameters that you can set to define priority and define resource minimums, et cetera. From a supportability perspective, we limit the amount of processor oversubscription on a host to 2 to 1. We think the best practice is 1 to 1. And I'll add one more caveat here that isn't really a supportability criterion, but is more just a general piece of guidance. Because of some of the things I described in the sizing session earlier today, we actually want to make sure that the number of visible CPUs on Exchange virtual machines is no more than you need. So, there might be a desire to size a virtual machine for 8 CPUs. And then because you have the ability in Hyper-V to just go ahead and give it 16, because that parameter is there. So go ahead and do that. Well, as I described earlier today in the sizing session, that's actually going to result in a fairly dramatic increase in memory utilization on the box, because there's some memory that's allocated on a per CPU basis. So you want to keep that number set to whatever the minimum was that you sized for when you ran through the sizing process, ideally in the role requirements calculator. That's something important to keep in mind with 2013. Hyper-V Replica is another fantastic feature in Server 2012. And it's a great feature for providing disaster recovery capability really to any application. Anything you can run on a virtual machine, you can now provide disaster recovery for using Hyper-V Replica. Very cool technology, not supported for Exchange 2013, or any version of Exchange for that matter. We have disaster recovery built into the Exchange product. We have a number of concerns about Hyper-V Replica and being able to truly support it for all the different possible deployment scenarios of Exchange. And so at the moment, it's not supported for a combination with Exchange 2013. If we change that in the future, realistically, it would probably be for a very, very small deployment, like maybe one server, because many of our concerns are around a multi-server deployment and keeping things in sync. But keep in mind that the disaster recovery capability that you get from Hyper-V Replica, you can actually get a better level of, or a more robust amount of disaster recovery capability, along with some great high availability features built into Exchange with a DAG. So that's really our recommendation. Use the features that are built into Exchange to get that, rather than using Replica. But by all means, deploy Replica for everything else, because it's fantastic. So sizing. We'll briefly talk about sizing. I think I only have a few slides here around sizing, and then we'll get to some of the problem areas that we're seeing these days and how to avoid them. So for CPU in a virtual deployment, what we typically see is that in a Hyper-V deployment, there's about a 10% impact around the additional CPU overhead that you need to plan for. So in the sizing process for Exchange, we come up with a number of megacycles, basically a unit of work, that are going to be required to support a given Exchange workload, a given number of users with a particular profile. And the way we deal with that when we think about sizing for virtualization is just to add 10%. It's a nice round number, easy to do the math. And this is actually included in the role requirements calculator. So if you go look at that calculator, you'll note that there is a yes or no option for server role virtualization. If you flip that to yes, all you're doing is adding 10% to your CPU requirements. If you're using another hypervisor other than Hyper-V, we recommend following the guidance of your hypervisor provider and adjust that 10% to whatever they tell you to set it to. They have a much better idea of what that number should be than we do, given the fact that they're going to be testing significantly more with their hypervisor and Exchange than we are. So we trust their guidance. And there's a hypervisor CPU adjustment factor field in the calculator where you can make that change. It's 10% by default, but you can change it to whatever you need to do that calculation. In terms of other resource impacts, when you virtualize Exchange, in general, memory is not impacted. There's certainly been a lot of talk lately around changes in Server 2012 around NUMA, non-uniform memory access. Exchange is not NUMA aware. So typically when we talk about NUMA, I kind of shrug and say, that's nice. There's nothing in the Exchange product that understands a NUMA topology or different path distance between a CPU and some set of memory. So in terms of how you would configure NUMA settings in a hypervisor deployment or in a virtualized deployment of Exchange, the simple answer is we don't really care all that much. But at the same time, there are optimizations in the operating system that we can take advantage of around NUMA. So we don't want you to not expose the NUMA topology to the operating system, as an example. We basically want to use the defaults effectively to make sure that the operating system can make good decisions around NUMA and do the right thing where it can. Storage should absolutely be optimized for I/O latency and high availability. That doesn't really sound like anything virtualization specific, and it's not. But in a virtual deployment, oftentimes there is, as I mentioned earlier, some more complexity in how you're getting to your storage. So sometimes there needs to be some additional thought around that connectivity and making sure that you can deliver basically the right service level of I/O to Exchange when it needs it. In general, really the message here, size for physical, and then map it to your virtual deployment. In an ideal world, we don't want there to be any difference whatsoever between our physical sizing guidance and our virtual sizing guidance. In fact, we don't really want there to be any difference in terms of how you would deploy a physical Exchange deployment and how you would deploy it on virtual machines. Virtual machine to us is the equivalent of a physical server. There's nothing in Exchange that knows that it's virtualized. It's just an instance of Windows. So there really shouldn't be a difference there. And that's really what we're trying to get across here. So size using the physical guidance that we've already produced, apply the CPU adjustment factor, and then deploy. Now, there are some caveats to that. This is probably the biggest one. So when you think about high availability, you do want to make sure that I'll get to that in a second. So when we think about interaction with other workloads, typically in a virtualized deployment, you're going to have some Exchange VMs running on your hypervisor hosts, and you're probably going to have some other things running there as well. Maybe some SQL, maybe some line of business apps, maybe some CRM tools, lots of things running in that deployment. We need to make sure that Exchange gets the resources that you sized for when it needs them. Exchange is a pretty resource-hungry application, and a lot of the issues that pop up when Exchange can't get access to those resources are actually passed on to end users. We are doing a better job in 2013 of trying to mask some of that and defer what I would consider background work if we need to in order to optimize for user experience through some of the workload management technology that we have in the product. But that doesn't solve everything. So the guidance here is really to use some of the reservation options that exist in hypervisors to make sure that Exchange can always get the resources that it needs when it needs them. Hyper-V has this. Basically, every virtualization product out there has these options today to be able to reserve resources for Exchange. That allows other workloads to take advantage of overcommit. So there are workloads out there that can absolutely operate well in an environment where resources are overcommitted. We totally recognize that. And if you go down the path of using reservations for Exchange, that gives you the freedom to do whatever you want with everything else and not isolate your Exchange virtual machines to separate physical hosts just for Exchange. Ideally, we want this better utilization of hardware, and we want to give you the freedom and the flexibility to run those Exchange VMs wherever you need to get the benefits from your virtualized platform. So reservations are a great way to do that. We do want to avoid getting into a situation where you have a massive number of Exchange users on a single physical host. Now, the definition of massive is going to change depending on specific situations. There's different user profiles, different aspects to that equation that are going to be different from company to company. But the key here is really that you want to spread out your Exchange mailbox servers as much as possible onto as many hypervisor hosts as you possibly can. You don't want to scale up and have 50 mailbox servers all on one physical host. What does that do for high availability? Really hurts it, right? The more you can spread out those virtual machines across multiple physical hosts, the better availability you have, because Exchange, through the DAG, is going to be able to do some fantastic things to ensure availability of the Exchange service when hardware fails. Hardware always fails. Software is always going to fail at some point. And from an Exchange perspective, we've done a lot of work over the last couple of releases to acknowledge that fact and design for that fact, and basically do the best that we possibly can when those failures occur to provide a great end-user experience. If we lose a physical host that has massive numbers of users, that's going to be a bad experience, right? Even if failovers do happen from a DAG perspective, that's still a huge number of users reconnecting, potentially overwhelming your CAS infrastructure, potentially overwhelming a load balancer. It's potentially overwhelming domain controllers from an authentication perspective. It's not a good situation. You want to minimize the impact of a hardware failure as much as possible, and spreading out mailbox servers is a great way to do that. So keep that in mind. So let's talk through some major problem areas that are popping up. And some of these will be a little bit repetitive, given that I've already talked through a good chunk of our best practices guidance. But these are coming primarily from support cases that have been escalated to the product group for various reasons, or from customer feedback that I've gotten directly over the last year or so. So this actually is basically what I was just referring to. So we want to avoid, wherever possible, scaling up and putting a lot of mailbox VMs on the same physical host. You also want to, and I'm not going to point any fingers or talk about company names or anything at that level of specificity, you also want to make sure that you're not hosting multiple copies of the same database on the same physical host. You don't want to deploy a DAG with multiple copies and then put those same copies on the same infrastructure, because there's no point in having multiple copies if they're all on the same infrastructure. You've just dramatically increased the amount of data that you're managing, that you're storing and managing and monitoring for no benefit. So be very careful about placement of mailbox databases. Also think about other aspects of your infrastructure that matter for Exchange. We have a huge dependency on Active Directory. Exchange does not do well when AD goes south, right? I'm sure many of you have had an experience where that's happened. Exchange needs a healthy Active Directory infrastructure. If you're virtualizing AD, think about how that's going to work in a failure scenario. Think about what's going to happen to your Exchange servers when problems occur with AD. Spread out those Active Directory domain controllers, your global catalogs, across multiple physical hosts, so that when failures do occur, you're not taking down multiple global catalogs simultaneously. And also think about where your witness servers live. If you're running in a site resilient situation and your witness servers happen to be sharing infrastructure with some of your mailbox servers, you may end up in a situation that you didn't exactly plan for, and your your fairly quick site switchover may turn into a much more painful experience as a result. So just think through all those different infrastructure pieces and think through basically for every failure domain, if the storage fails, if the connectivity to the storage fails, if a particular server fails, what's going to be the impact in that environment? Having a great plan for that really helps with availability. Around host-based failover clustering, we do see a lot of people interested in deploying this with Exchange, and that's fine. We absolutely support it. My ask to you is to go for the belt and suspenders method. Take advantage of host-based failover clustering, but use it in combination with a DAG. You're going to get your high availability from a DAG. You're not going to get it from host-based failover clustering. What you will get from host-based failover clustering is your mailbox servers coming online quicker after some sort of a failure at the physical host level or the physical infrastructure level, because host-based failover clustering will move that VM to a healthy system and bring it online. So that means DAG replication is going to get healthier quicker, less manual intervention to bring that virtual machine or set of virtual machines back online. That's great. But in terms of the immediate impact and the immediate access to data that your users require, that's going to come from having a database availability group. It's going to come from the DAG. So use the combination. Don't just deploy host-based failover clustering. You'll have a much better experience with the combo. So we talked a little bit about the memory mess around dynamic memory and other similar technologies. So the challenge for us, just so you have the background, this will probably be the last TechEd I show these slides, because I showed them last year as well. Don't want to be too repetitive. What we end up with dynamic memory, in the situation where an Exchange virtual machine is configured for dynamic memory and another workload running on the same physical host requires some memory that Exchange is currently using, is a situation where database cache effectively ends up getting served from the page file. That's not a good situation to be in, and it means, most likely, that I/O, particularly to the page file drive, is going to go through the roof. You're going to end up with a very unhealthy Exchange server, and that's going to be passed on to your end users. They're going to feel pain in terms of RPC latencies that will be reflected as lags when making OR requests, delayed mail, a number of different ways in which that will show up. So the best practice here to avoid this, as I mentioned earlier, statically configure memory for Exchange VMs. Very simple to avoid this problem. Just statically configure memory. Make sure that Exchange always gets that memory that it was sized for. So what this actually looks like visually, we've got a couple of charts here. One of them, the first one, overlays RPC average latency over a period of time with the available bytes counter, which is a memory counter. And what you're basically seeing is a period of time where an Exchange virtual machine was put under extreme memory pressure. And what actually happened here is that Hyper-V dynamic memory went in and forcibly took some memory from this virtual machine. So the machine goes into massive amount of memory pressure, where the green line drops dramatically, falls off the cliff. That's where we're under memory pressure. RPC average latency goes up very noticeably, right? That's going to be felt by end users. And then when the machine recovers, when that memory was able to be reclaimed, the Exchange system gets healthy again. So if we look in a little more detail at what actually happened behind the scenes, the counter that I'm showing here is transition pages repurposed per second. What is that? That's actually a great counter that defines memory pressure on the box. When we used to dynamically tune the amount of memory that Jet, our database engine, used for cache, the way that we determined whether or not we were under memory pressure was via this counter. So at the point that counter starts spiking, we would have actually dramatically reduced the amount of memory we were using for cache. We don't do that dynamic tuning anymore. We lock the amount of cache that we use in when the store process starts up. But this is an indication that during this time period, we were under a massive amount of memory pressure. The next counter here is pages output per second. That actually has a number of definitions. There's a few things that show up in that counter. What I'm going to use it to represent here is actually pages being written, memory pages being written to the page file, which is the vast majority of what this is reflecting in this chart. And then I overlay that with working set, which is in this case, the sum of the amount of RAM being used by every process on the box, the amount of physical memory, not virtual memory, but physical RAM being used by every process on the box. So what's happening here is we go under memory pressure, and the working set drops dramatically. This is the store working set specifically. It dropped dramatically. What we're seeing here is dynamic memory came in, and through a process called ballooning, forced working set trims, basically forced all the processes on the box to give up memory. It said, give me whatever you possibly can, and then some. So store did exactly that, and it paged out a whole bunch of its memory, including a bunch of database cache to the page file. And there's the available bytes counter as well. So that resulted in the RPC average latency increase, and that would result in probably a very nasty incident from an exchange perspective, visible to your end users. So avoid this problem, statically configure memory, that's all you got to do. Around migration, this has been more of a problem lately for some reason, and I don't know if it's because we have more people taking advantage of migration, or maybe more people using live migration and vMotion with servers that are running at larger scale, so they have more churn in terms of memory. Not quite sure what the reason is, but it's been popping up more lately. When migrations occur, the goal is always to have those migrations occur where the virtual machine being migrated is online for the duration of the migration. That's the whole idea behind the technology. The challenge is that at the end of each migration, there's always what we call a brownout period. There's a time where basically the migration is finalized. It's going to be potentially a couple seconds, maybe a little bit longer than that, where it's less than a TCP timeout window, basically. So clients aren't going to feel pain from a connectivity perspective, but that machine is actually not reachable if another machine on the network goes and pings it and expects an immediate response. So in a DAG, we're actually using Windows cluster technology behind the scenes for what we call, or what the Windows team calls, heartbeating. That's where machines in the cluster are making sure that they can reach each other. That's how we detect failure, right? If a machine goes offline, we can then detect that failure using those Windows clustering components and fail over active copies of databases and bring service back online. If a virtual machine is being migrated and that machine is offline for a long enough period, 5 seconds by default, then that machine will be detected as unavailable, unreachable, down. And as a result, it'll basically get kicked out of the DAG. Any active copies, database copies that were active on that mailbox server will then be activated on other mailbox servers in the topology. And you may end up with some interesting results around replication, needing to make some manual intervention to go get replication to that mailbox server healthy again. Doesn't always happen, but it can. I've certainly seen it happen many times. The goal here should always be to minimize that brownout period. If you can keep it below 5 seconds, fantastic. That means everything's just going to work out of the box, and that's the best possible scenario. The technology just works for you, and you don't have to worry about anything else. However, if you can't get that to happen within 5 seconds for whatever reason, there are ways to adjust that, where you can basically adjust the timeout settings associated with this technology. So I show some PowerShell here that you can use to do that. This is showing the settings for cluster nodes that are within the same subnet. There's also equivalent settings for outside of the same subnet as well that you can go get some documentation on in TechNet. So these are the default settings that I show here. The threshold's equal to 5, the delay is equal to 1,000. This is basically 5 pings of 1,000 milliseconds each. So 5 seconds is the timeout. If you wanted to change this to 10 seconds, double one of them. Change the 5 to 10 or the 1,000 to 2,000, either one. It doesn't really make much difference. You don't want this to be too big. If you make this number too big, What that means is that you're going to have a delay if a server actually fails before the DAG will take notice and actually fail over active copies of databases and bring service back online. So there's a kind of a delicate balance here if you go and adjust these numbers. So like I said, if you can do this within 5 seconds and optimize the network, do whatever you need to do to keep it under that time, that's a much better way to go than manually adjusting these numbers. Let's talk briefly about snapshots. So as I mentioned, hypervisor snapshots are great for lab testing. We love them. Can't live without them. From the perspective of Exchange and snapshots, log shipping is probably the biggest example of where we have problems. Prior to Exchange 2013, I would argue public folders is probably the area that I would be most worried about from this perspective, given that we had how can I put this nicely? Kind of a crappy replication system for public folders in 2010 and earlier. It didn't deal well with unknowns, let's put it that way. So, if you had machines in the public folder infrastructure that were kind of jumping around from a time perspective all over the place, public folder replication was designed at a time when no concept of that existed. Time travel did not exist when that was designed. Not so much the case with modern public folders, but we still have issues with log replication in a DAG in this scenario. So even in the lab, I've seen this be a problem. You do need to be careful if you're testing in a lab and you have a DAG, that you absolutely snapshot all the machines that are participating in that DAG simultaneously and roll back to those simultaneously. But I've actually run into cases where those snapshots have taken a chunk of time and have actually ended up getting into this scenario where while that snapshot was occurring due to performance on the hypervisor host, you ended up getting DAG nodes evicted and databases failing over, which I thought was kind of an interesting combination of failures. So just be aware that this doesn't work great with Exchange. We're not really designed to work great in this scenario. So problems can occur. We don't support it in production. Sort of a best effort and test. Just be aware of that. So around CPU oversubscription, I mentioned that we don't like it from a sizing perspective. As I point out on the slide, hypervisors are very cool, but they don't do magic around CPU. Just because they can present additional virtual CPUs to the virtual machines that are running on a physical host doesn't make CPU resources magically appear. Yes, if other workloads aren't fully utilizing CPU at some moment in time, other workloads can take advantage of that. That is the benefit to CPU oversubscription. But in an ideal world, you don't have that scenario. You've sized things properly such that you're not running into that case. So it can help with hardware consolidation in that case where things aren't sized very well. But from an Exchange perspective, like I said, we want the resources available to us when we need them to provide a great end-user experience. So what does a CPU-constrained Exchange server look like? And these are examples that have shown up in support cases that I've seen over the years with CPU oversubscription. So you can get delivery throughput reduction. Right? If we don't have the CPU resources to deal with a mailbox delivery of a transport item, well, we're going to grow queues. That's not a good place to be as an Exchange admin. We don't want transport queues, except for maybe outbound queues to the internet, which we're likely always going to have a little bit of. We never want queues internally delivering to our own local databases. That's not a healthy place to be. We can also end up with content indexing throughput reduction. That means that CI isn't keeping up with the rate of change in a mailbox database. Now, ideally, content indexing is actually going to index things as they're being changed, which means as they're in database cache, they're in memory. So CI essentially has very quick access to that information and doesn't have to go to disk through store to get that information. If CI gets behind, that means that the indexing process is now going to be pulling content off the disk to get to it, which means your IOPS is going to go up, potentially pretty dramatically. Also a bad place to be. And then the last case is probably the most obvious. If we're CPU constrained, RPC operations to the store are going to take longer, and that means that every user transaction, whether it's looking at a calendar, an OA, sending a mail, whatever, all of those are going to take longer, and we don't want that. So coming to the end here, one of the last pieces I want to touch on is a new component that's in Exchange 2013 called workload management. I mentioned it briefly earlier. So we're trying to add a little more intelligence in the product around better utilizing hardware. And the idea here is that Exchange has a bunch of work that it does that isn't critical to transactions, right? Generating an OAB has nothing to do with me sending a mail. Well, having that access to the OAB might be useful for me to send the email, but the process of generating that OAB or updating that OAB behind the scenes on Exchange is a background task. It doesn't need to happen generally at a particular moment in time. Running some sort of background integrity checking process on store, also a background task. Doesn't need to happen at a particular moment in time. Historically, we've run these types of things in the middle of the night. Makes sense, right? You have a reduced workload in the middle of the night, great time to run background tasks. We have a slightly different way of dealing with it in 2013, and that's to actually monitor performance on the system on an ongoing basis and figuring out when the amount of load being placed on the system by users is low and kick off some of that background workload during that time period. When load picks up again, then we'll reduce the amount of background tasks that we're running. We do this with a number of different types of load. Mailbox moves through the mailbox replication service is a great example of this. If CPU is high on a particular mailbox server, then we will very dramatically throttle back mailbox migration, potentially completely stopping it as a result of workload management. But at the same time, if a server is very underloaded, we'll dramatically increase the concurrency of mailbox moves to take advantage of those resources. The challenge with that is that if those resources aren't consistent, if they're not always there, if they're changing underneath us at any point in time, workload management has no idea how to deal with that. So what you end up with is a case where workload management can make the wrong decisions, and your hypervisor can be adding and removing resources, and workload management can be trying to optimize utilization of resources, and they end up butting heads and not doing the right thing for you as an IT pro and your end users in terms of user experience. So just be aware of that. This is something that you can run into if you don't statically configure resources for Exchange. So to kind of close things out here, virtualization of Exchange 2013, absolutely supported. There are a few limitations that we talked through, but absolutely supported. The vast majority of you in the room raised your hand when I asked who's virtualizing Exchange today, so you guys know that. You know that Exchange is virtualizable. Robert back there in the corner is absolutely virtualizing Exchange. Oh, hi, Robert. How's it going? Be aware that it's not always the right choice to virtualize Exchange, right? It may be for particular cases. It's not always the right decision. Make sure that you're getting something out of it if you choose to go down that path. Don't do it just because you virtualize everything. You want to make sure that you're taking advantage of some of that additional functionality that you get with that layer. Don't oversubscribe. I don't think I've said that enough today. Statically map resources. Make sure that memory is statically mapped. Don't use dynamic memory, memory oversubscription, memory overcommit, blah, blah, blah. And make sure that processor resources are always there when Exchange needs them. And then in terms of functionality, there are things that are provided by the hypervisor. Host-based failover clustering, Hyper-V replica, things that Exchange actually in many cases provides a replacement for, where you get a better outcome by using the functionality that's closer to the application. So using a DAG to provide high availability instead of host-based failover clustering. Using a DAG to provide some site resilience as well, avoiding using replica. Those are important considerations. So with that, I will point you to some related content. There's actually a huge amount of virtualization content at TechEd. The Windows Server team is very active in talking through their new features in Server 2012 and talking about the future as well. So these are some good sessions that I pulled out that I think are relevant to folks who are considering virtualizing Exchange, worth taking a look at. I will be at Ask the Experts later this evening at 6:30, somewhere downstairs. I don't know exactly where it is. So if you have further questions, feel free to come grab me there. And I will have a few minutes to answer questions here as well. And with that, I will call it good.